This is Unit 5, Right Triangles, Lesson 5.4, SOH CAH TOA. Please make note of both the location that you're watching the videos, the date and time, and don't forget to get a parent, guardian, or teacher sign-off. This is by far the most important lesson of the entire year that you are about to watch. It is the introduction to what's commonly called trigonometry. Some of you will be studying an entire year based upon the basic concepts that I'm introducing. So it's really, really important over the next 40 minutes that you are absolutely focused. We're going to take this in little tiny baby steps. First, we're going to review our last lesson. In the last lesson, we talked about special right triangles. And there are two special right triangles. Those two special right triangles are the 45, 45, 90, where the legs are equal and the hypo is whatever the leg is times root 2. And then we have the 30, 60, 90. Let's see what we might use here. In here, we have a 90, a 60, so this must be a 30 degree. So we have a 30, 60, 90 degree triangle. And in that triangle, let's draw our little table. We have the short leg, the long leg, and the hypo. Whatever the short leg is, the hypo is going to be double. So it's 2 times the short leg. The long leg is whatever the short leg is times root 3. Short leg times root 3. That's the long leg. Now let's identify what we have here. 60 is our larger angle, so this is the long leg. So what we have here is the short leg times root 3 gave us the long leg. So it looks like this. Something times root 3 gave us 8 root 3. From this, it's really easy to see that the short leg had to have been 8. To get to the hypo, you take the short leg and we simply times by 2. So in this case, 8 times 2, our A is going to be 16. So it's really, really important that you memorize these two tables, the 30, 60, 90 table and the 45, 45, 90 table. Okay, so you've learned so far what to do if you have two sides of a triangle. So if you have two sides and you need to get the third side, we use the Pythagorean theorem. Or if we have one side and either a 45, 45, 90 or a 30, 60, 90. But you ask yourself, what if it's not 45? What if it's 47 degrees? What happens then? That's what we're going to be learning today. So far in right triangles, we've talked about geometric means, Pythagorean theorem, and special right triangles. Make sure you've memorized everything from those three sections. So, again, what if the angles are not even, like 45, 30, and 60, and 90? How do we find missing sides then? There are things that we're going to be learning called ratios. Underline that word ratios, and I want you to draw an arrow. Don't let, it's ratios, not rations, ratios. Don't let that word intimidate you. Remember, a ratio is just a fraction. So just draw something over something. Now, as we use these ratios, to use these ratios, you must first learn to label a right triangle with these three terms. The hypotenuse, and then the term opposite, and the term adjacent. The hypotenuse, the opposite, and the adjacent. Let me show you how to label those. And as we're doing today's lesson, we're going to use this Greek symbol. That symbol is called theta to represent an unknown angle. For example, in algebra, we use x to represent an unknown number. And when we deal with trigonometry, we use theta to deal with an unknown angle. So hypotenuse, opposite, and adjacent. Those are the terms we're going to work with. Let me show you how to find those. Step one, we have our right angle. Now when I talk about the unknown angle, I never mean the right angle. It's always one of the acute angles. So here is our theta, or our unknown angle. Just physically sweep it. Step two, we're going to find the hypo. Hypo is always across from the right angle. So you find the right angle and you write hypo. Now, which one's opposite and which one's adjacent? If this is our theta, sweep it again. Now draw an arrow from theta pointing to the opposite side. The side opposite of the theta, that's called opposite. And then adjacent means next to. In this case, adjacent would be here. Let's try the one rotated. First, we trace the right angle, we go across from the right angle, and we find the hypo. 2, we sweep the theta, or the angle that we're working with, and we go across from the theta. That's called the opposite. So here is opposite. And then right next to theta is going to be the adjacent. Very important you are able to label these. What I like to do to remember these, I call this HOA. Hypo, opposite, and adjacent. Now, how do you use this? Okay, so here we sweep the right angle, and first we're going to identify our hypo across from the right angle. So here's the hypo. 2, we sweep our theta. The theta is the angle we're working with. In this case, our theta is going to be 32 degrees. Now we go opposite of the theta, and we label. That's our opposite, which to this angle, 5 is adjacent, or the 15 is adjacent. Again, you're trying to label hypo, opposite, and adjacent. I like you to actually pause the video and take 1 minute and attempt to label both of these. Hypo, sweep the given angle, and label the hypotenuse, the opposite, and the adjacent. Identify the x and y as the hypotenuse, the opposite, or adjacent. Ready? Take 1 minute and label these. Go. Okay, so here, let's check. First, let's find our hypo. There's our right angle, which makes that our hypo. Now, here's our theta. We go across from our given angle. That makes y the opposite. And in this case, that makes x the adjacent. Over here, we start with the right angle, and we identify y is the hypo. Then we have our given angle, 21, and across from 21 is the 8, so 8 is opposite. This side is the opposite, and that makes this the adjacent. It is absolutely critical that you are able to identify the hypo, the opposite, and the adjacent. That's step number 1. Now we're going to talk about ratios. Remember, ratios, that word ratio just means a fraction. Once again, go a little something over something. So in this given triangle, we're going to sweep angle A, and we're going to label the opposite, the adjacent, and hypo. So let's sweep angle A. If that's angle A, that means 3 is our opposite. And that means 4 here is our adjacent side. And then we have here our right angle, so that makes 5 our hypo. Now we're going to make ratios or fractions of these sides. So we're going to take the opposite over and put it over the hypo. So our opposite is 3 and our hypo is 5. So we're going to go 3 divided by 5. That is your 1 ratio, and then also I want you to get the decimal version of that. So we're going to go 3 divided by 5, and I'd like you to take it to the 4th decimal place. That's 0.6. So it's going to come out as 0.6000. Please take that to the 4th decimal place. That's 1 ratio. Opposite over hypo. I like you to put here OH. Opposite over hypo. Now we're going to try another ratio. Now we're going to do adjacent over hypo. So our adjacent is 4, and our hypo again is 5. So we do 5. And we're going to divide 4 divided by 5, and that's 0.8. So 0.8000. This was adjacent over hypo, AH. Now the last one, we're going to do opposite over adjacent. That's going to be OA. So our opposite again is 3. Our adjacent is 4. And you shouldn't need a calculator for this. 3/4 of a dollar is 0.75 or 75 cents, so 7500. So what we have found, we've taken the sides of a right triangle and we've made various ratios or fractions. We've done opposite over hypo, adjacent over hypo, and opposite over adjacent. These 3 ratios have names. These 3 ratios have names. The opposite over hypo ratio is called the sine ratio. Sine, put a giant S there. The adjacent over hypo is called the cosine ratio. Put a C there. And the opposite over adjacent ratio is called the tangent ratio. Put a T. Sine, cosine, and tangent. These ratios have names. Sine, cosine, and tangent. Sine means opposite over hypo. Cosine means adjacent over hypo. And tangent means opposite over adjacent. when we use the first letters of all these words, we get the acronym SO CAH TOA. Say it out loud with me. SO CAH TOA. Say it like you're chanting it at a summer camp. SO CAH TOA. Yeah, I mean it. Say it to yourself, please. Okay, so these ratios have very particular meanings. I'm going to show you how to use these. So, for example, we're going to find the required ratios in the given triangle round to the 4th decimal place. I'm going to try to find the cosine of A. So the way I do that is the cosine, I look up here, cosine is adjacent over hypo. So the first thing I'm going to do is I'm going to label the opposite, the adjacent, and the hypo. 40 is the hypo. And if I'm using A as my angle reference, that means 24 is my opposite and 32 is my adjacent. Now it says the cosine of angle A. That's why I swept angle A. So I look up here and cosine, I write it out, cosine of the angle equals adjacent over the hypo. So the cosine of angle A equals adjacent, which in this case is 32, over hypo, which in this case is 40. And then I'm going to take that and round 32 divided by 40 to the 4th decimal place, and I get 0.8. So 0.8000. So the cosine of angle A, the cosine ratio of angle A is going to be 0.8000. I like you to follow this example, and I'd like you to do the tangent of A in this diagram, the tangent of A, and here I'd like you to find the sine of Z, the sine ratio. I'm going to give you 1 minute. Ready? Go. Let's see how you did. Okay, tangent, the definition of tangent, the tangent of an angle equals, it's TOA, T-O-A, equals opposite over adjacent. That's the basic definition. Now let's look here. From angle A, 8 is the opposite, and 15 is the adjacent. 17 is the hypo. That's not in play when you're using tangent. So if I'm going to do opposite over adjacent, I'm going to do opposite, which is 8 over 15. And then in the calculator, I'm going to go ahead and go 8 divided by 15. And we get 5.33333 repeating, so I'm going to go like this. In this case, the tangent of angle A is 0.5333. Now let's come over here and find the sine of z. We know the sine of an angle, that's the sine ratio. Sine is SOH, is going to be opposite over the hypo. And in this case, the opposite is going to be 12. And the hypo across from the right angle is going to be 37. So now we're going to do 12 divided by 37 in your calculator. 12 divided by 37. Take it to the fourth decimal place, 0.3243. So in this case, the sine of z is equal to 0.3243. Okay, these are called the ratios. Again, ratios are just fractions. Now, what do you do with these ratios? It's nice to know that you can make these lovely fractions of opposite, adjacent, and hypo, but what can you do with them? There's two major things that you can do. You can, when you have a right triangle, the first thing you will always do is label the opposite, the adjacent, and hypo, depending on where your unknown angle is. And there's two things you can do to work with. You can find sides using this, and you can find angles. Sides and angles. I'm going to show you how to do both. Sides and angles. The first one, we're going to look how to do sides. How to do sides. You want to have this portion of your reference sheet out. And here are the steps we're going to follow. Step number one is we start by labeling opposite, adjacent, and hypo. To find the side of a right triangle, we're going to find out what we have and what we need to determine what we do. And we're going to choose a proportion and solve using the sine, cosine, or tangent ratios. I'm going to take this step by step, very slowly. Okay, so let's start by labeling. We always start by labeling HOA, opposite, adjacent, and hypo. So in this triangle, and draw this really carefully. In this triangle, this is our hypo, because it's across from the right angle. Now this is our theta, our given angle. That means we go like that, draw an arrow. That means x here is your opposite. And this 15 here is the adjacent. Ready? Here's the secret sauce. Here's the special secret, the shortcut to everything in this lesson. These three words: have, need, do. Underline and say them out loud with me again. Ready? Have, need, do. I'll walk this through with you. Look at what we have. We have 15. Which is the adjacent. So I'm going to write, I have the adjacent side. If I want to find x, I look x, circle it, I need the opposite. Now look very carefully. I have an adjacent, I need an opposite. Ask yourself, in SOH CAH TOA, what goes with OA? Look over here very carefully on this sheet. In SOH CAH TOA. Let me write it a little bit bigger. SOH CAH TOA. Which one of these works with OA? Look really carefully. You should notice it's tangent. So now what do? We're going to start by writing out the tangent proportion. Just write it exactly as you see it. Ready? Tangent. I'm going to write tan. That's the shortcut. Tan of theta over 1 equals the opposite over the adjacent. You always put opposite over adjacent. Okay, now we're going to plug it in step by step. Tangent. Our theta is 32 degrees, so we write tangent of 32 degrees. Whoops, not 33, 32. And put parentheses around that because that is a single unit. This is not 32 and tan 32 are not the same thing. So it's tan 32. Tan 32 over 1 equals our opposite, which we don't know, we're going to call it x, over adjacent, which is 15. All right? Next step. We're going to cross multiply. Next line reads 1 times x equals parentheses tan 32 degrees times 15. So to solve for x, we basically have to find the tangent of 32 degrees and times it by 15. Now the question remains, where on earth do I get that value? Okay, remember it's not 32. Please put this in the margin. 32 and tan 32 are not the same thing. So that's why you keep parentheses. How do you find tan 32? Two different ways. Depending on your calculator, it's really important you check this on your calculator. Okay, if you have the TI-30XA, what you're going to do is you put in 32 and then you hit the tangent button. Oh, well, here we want to find the sine, but it's a tangent button. Okay, this is what I want you to find on your calculators. Get out your calculators, and we're going to see which way yours go. In this case, we're doing tan 32. So you either do tangent and then 32 and hit an equal sign, or you do 32 tangent. On your calculator, figure out which one it is right now. Yours should match mine, 0.624869, etc. You need to make sure you're in what's called degree mode. Again, on my computer calculator, it's 32 and then tan. On some of your calculators, it's going to be tan 32. So I'm going to take that to the fourth decimal place, 0.6249. So x equals 0.6249 times 15. So I'm going to take this, I'm going to times by 15, and I get my answer for x, which is going to be 9.373. Take your final answer to the first decimal place, so it's 9.4. I don't expect you to understand this right away. We're going to do this a couple more times. So once again, in your calculators, if I wanted to find the sine of 32, on the smaller calculators, I'd hit 32, then the word sine, or on the larger calculators, you hit sine first, then 32. Let's do another one together. Ready? Step one is we're going to label opposite, adjacent, and hypo. Here's our right angle, here's our hypo. Here's our theta, that makes x the opposite, and that makes 15 the adjacent. Now, have, need, do. I have the adjacent. I want, in this case, if I want to find y, I'm going to find the hypo. Now I have an AH combination, an AH combination. Over here, let's write our acronyms. SOH CAH TOA. To figure out what you do, you ask yourself what goes with AH. And it's C, which is the cosine ratio. On your little sheet here, the cosine ratio is right here. We're going to write it down. The cosine of angle theta over 1 equals adjacent over hypo. That's the cosine ratio. Now we're going to circle, plug, chug. We know the cosine. I'm going to write cosine 32 degrees, parentheses, over 1 equals adjacent, which in this case is 15, over our hypo, which is y. Now we're going to cross multiply. So next step, 15 equals cosine 32 degrees, parentheses, do not drop those parentheses, times y. Now, we want to get y by itself. We want to get y all by itself, so I'm going to divide both sides by cosine 32 degrees. These cancel. So the final step, if I want to find out what y is, it equals whatever 15 is divided by the cosine of 32 degrees. That's going to be 15 divided by, now how do I find cosine 32? You get out your calculator, and either you do 32 cosine or cosine 32. In my case, I'm going to do 32. I'm going to hit the cosine button. I take it to the fourth decimal place, 0.8480. 0.8480. So to find y, I'm going to do 15 divided by 0.8480. So I clear. I'm going to 15 divided by 0.8480 equals, I get 17.7. So our hypo here is going to be 17.7 degrees, or 7, whatever the units are. Study this very carefully, and then I'd like you to come and just do your best that you can to figure this one out here, the U-try. I'm going to give you 5 minutes. Do the best that you can on the U-try. I'm not going to give you 5 minutes. I'm going to give you 3 minutes. I think you can manage this in 3 minutes. Okay, let's take a look and see how you did. First, let's label our opposite, adjacent, and hypo. If this is your right angle, that makes 21 your hypo, so we're going to put hypo there. That makes this our opposite, and our x is our adjacent. What do we have? We have our hypo, so we write hypo here. And we want our adjacent. So we have to figure out, using SOH CAH TOA, which ratio we're going to work with. We have an H and an A. And which ratio uses the HA combination? That's cosine. So we write out our ratio. Cosine of theta over 1 equals always adjacent over hypo. Even though we have the hypo, it's always going to be A over H regardless. Now we're going to circle, plug, chug. Cosine of theta, our theta here is 18, so we write cosine, COS, 18 degrees, parentheses, over 1, equals adjacent, which is our x, over hypo, which is 21. Now we cross multiply. So we get x equals cosine of 18 degrees times 21. So now how do you figure out cosine 18? This is where you get your calculator. And you either do cosine 18 or 18 cosine. My calculator is 18 cosine. And I get 0.95105, but I'm going to round to the 10th, so that's 9511. So my x is going to equal 0.9511 times 21. So in this case, I simply times by 21, and I get 19.97. And since I've told you you can round to the nearest tenth, this actually bumps up, so we're going to call this 20. So that's how you find a side. Let's try another one together. Ready? Have, need, do. We have, let's label everything. There's our right angle. Here's our hypo. 21 is our theta, so that makes this our opposite, and this our adjacent. We have the hypo, which is 16, and in this case we want the opposite. So we have an OH combination, and the acronym is SOH CAH TOA. You see what goes with OH is sine, so we write that out. Sine of theta over 1 equals opposite over hypo. That is the sine ratio. Now we circle, plug, chug. Sine of our theta is 21 degrees, so sine 24 degrees over 1 equals opposite, which is our x, over hypo, which is our 16. Now we're going to cross multiply. We get x times 1 equals 16 times sine of 24 degrees. Sine 24, in my calculator here, we're going to go 2, 4 sine. And we get 0.4067. Times 16 equals our x. And we're going to end up with 6.5 is x. You're going to get better at this as you get practice, practice, practice. Okay, another thing you're going to be looking for is angles. And when you're working with angles, you start by labeling opposite, adjacent, and hypo. Determine have, need, do, but now you're going to use what's called inverse cosine, inverse sine, and inverse tangent. It looks like this. Inverse sine is sine -1. Inverse cosine is cosine -1. Inverse tangent. Another word for inverse, you might see this in another textbook, is arc. So we take a look here. Inverse sine opposite over hypo gives you the angle. Inverse cosine adjacent over hypo gives you the angle. Inverse tangent opposite over adjacent gives you the angle. These are called the inverse, also known as arc. You must memorize these. Now, when you're looking for the angle, this is the only time that you're going to use your shift or second function key. This second function key you only use when you're looking for the angle. Do not touch it otherwise. Now I'm going to show you how to use that button in just a moment. To find a missing angle, step 1 is you label everything. Here's your right angle, here's hypo. Here's our desired angle. We don't know it, but this is the opposite. And this would be the adjacent of that angle. So let's look at what we're working with. We're working with O and A. Now you ask yourself, what goes with OA and SOH CAH TOA? We see here that tangent works with O and A. So we write this out. The inverse tangent opposite, let me keep my colors straight here, opposite over the adjacent gives us the angle. All right, so on our calculator, it's going to be inverse tangent, so it's tan -1. Our opposite is going to be 22. Our adjacent is going to be 34. And that's going to give us our angle. Now, how do you do this on your calculator? There's two ways. Okay, on the smaller calculators, we do 23 divided by 24 first, then hit the second function, and then the tangent. Get this nice and big. So if I want inverse tan, I do 23 divided by 24, I get a decimal, and then I hit the second function and then the tangent button. On these larger calculators, you do second function first, then the tangent button, and then the decimal. On my computer calculator, it's going to look like this. We're going to go 22 divided by 34 equals, now watch what I hit. I hit inverse. That's also the same as second function. Inverse tangent, tan -1. And I get 32.9 degrees, and degrees we're just going to round to the nearest whole number. So I get 33 degrees. So my angle here is 33 degrees. We're going to do this again. I know you're just about getting braid fried right now. If you need to take just a minute off, do so, but come right back. Ready? Okay, let's take a look at this one. This one, we have the hypo and the opposite, and we want the angle. So this is an OH combination, which I know is sine, so I write it out. Inverse sine opposite over hypo gives me the angle. Inverse sine, our opposite is 13 over hypo 14, gives us the angle. On the computer calculator, I'm going to do 13 divided by 14. You get a decimal, and then to get the inverse, you hit that inverse button or second function button. So I'm going to hit inverse, sine, see that sine -1, and I get 68 degrees. So my angle here is going to be 68 degrees. I'd like you to take 3 minutes and attempt to do this last problem on your own. 3 minutes. Or I think you can do this faster. Let's give yourself 2 minutes here. Go. Okay, let's see how you did here. Last one. Okay, this is our hypo, and this is our adjacent. That is an AH combination, AH, which means you should have used cosine, which looks like this. Inverse cosine, adjacent over hypo, will give you the angle. So it's inverse adjacent 20 over hypo 48 gives you the angle. So on your calculators, and my computer calculator, I'm going to do 20 divided by 48, and I get my decimal, and then I'm going to do inverse cosine. There's cosine -1, and I get 65.3 degrees, so I'm going to use 65. So this angle here is 65 degrees. If you actually got yourself on your own, give yourself a great big smiley face. That was a very difficult problem. Can't wait to see you in the classroom, students. Trust me, this is the longest preview note of the year. Every one of them will be shorter than this. If you actually watch this to the very end, congratulations.